So I would like to start the lecture, the capability of emergent intelligence for the robot living in the symbiosis environment with humans, in a part of the introduction to the AI and robotics. This is Hiroaki Wagatsuma, Kyushu Institute of Technology. I will explain the issue on how do we define robot, the kind of purpose of the robot as an introduction. I will show you here a kind of map, the two axes, morphology and the purposes. Right side is the scientific issues, left side is the engineering issues. Rocket is a very wonderful technique, but it's still unclear. It's not daily things for us. That's why we need a lot of investigation to improve the method or technology. That's why rocket, space aircraft is in a sense of the scientific issue. Airplane automation in the factory is very daily things. We see the stair, the wheel, the caterpillar, the elevator in so many places. We need to think for the improvement on them. That's why still there are some issues on that, but it's the kind of engineering we can think about to be better technology from this. Let me think. A humanoid robot or rescue robot, this is okay, but it's still a bit far from our daily life. That's why we need to think about what kind of robot can help us in the daily life. Here, I would like to recommend you to think about our consciousness. What is the consciousness, or what is the awareness? Firstly, this is a scene. Robot is waiting in the refrigerator, then try to get a kind of cool drink bottle. The necessary skill, accurate motor control, object recognition, matching pursuit, to be safe to use the machine or the facility, the system. So this is a very advanced engineering issue for us to study. Of course, very important. But besides on this, how robot can think? This is a hot summer. A cool drink is very nice. How robot can think this kind of things? This is a question here. This is my hypothesis to think about what kind of information processing is going on in the processes. The most important things is matching between the top and the bottom up processes. I will show you yellow boxes. Usually, a roboticist design the program to control robots accurately or find recognition object. That's why robots can behave a specific behavior or to solve a kind of mission. This corresponds to the right side. Robot try to grab blue ball. This is a kind of event. Then they try to do some operation. Then they have to regulate or feedback control with respect to the relationship. This is most important things for designing a robot, but in usual cases for us, that operation should be matched your intention. What kind of things you want to do now? What kind of meaning it has? Or what kind of type of the things existing in the world, in the concept. It's highly important to do complex task execution That's why yellow box again, recognition, what I intend. Top down, the composition of the what you have to do is very important. Then the meaning of the understanding is to connect two layers sacredly. That's why top down and the bottom up sacredly continue in the interaction. The bottom picture, okay, let's say this is the kind of the puzzle. You have to do some action to solve the puzzle, but you have to recognize the action is proper or not to solve the problem. That's why, okay, our intelligence is situation or context dependent. It's highly dependent on personal issue or individual. That is biological information. It requires different time scales to treat meaning and the quality of the information. Let's say temporal granularity. One of the important concepts to think this issue is called situated cognition and temporal granularity. This is an example to think about this issue. We can think, oh, we are going to home. No, we are going work or study. Or you're working in the office. This is the kind of intention, what you want to do now. Go to work can be decomposed. A primitive concept, go out of home, drive the car. Go out of home, correspond the combination, lock the door, entering a parking space, or driving car, correspond riding the car, drive the car, steering, so. This is kind of primitive motion control or some primitive action planning. You're going at work for work in the office. You may start checking to the email. It also can be decomposed. Yes, it includes the type of the keyboard, but just typing keyword can be monitored externally. It cannot be specified whether you are doing work or playing game or just web searching for your next adventure. That's why blue letter, this kind of components can be organized to represent some specific things. That's why how this related to the situation. This is one point. Red letter, where is the conscious state necessarily, which level. This is very important to think how robot can automatically or artificially think like human being. This is schematic illustration to explain the process composition and decomposition. As I explained, yes, go to work is composed the component or element that go out of home, go to office. It may include again, drive the car or catch train selectively. This component also included the mission, come back home after working. If it's Sunday or weekend, you may go for shopping. With a large number of the components is overlapped with respect to that go to work. This represents situation-dependent grouping or organization is highly important for our intelligence to do some complex works. Right side, you can see yellow balls, nodes, green nodes. This is a decomposition process. If you have some specific intention, it can be decomposed more primitive concept. In the bottom level, so many information arises from the environment or your body or some other places. Then you try to connect them together. Then you can think, okay, I'm grabbing the key of the door. I'm looking at the key, the door, the key by the key. Then go out of the home. This matching process is highly important to reproduce our intelligence if you try to implement this kind of things into your robot. This is a map of strengths and weakness in recent AI technology. I drew the line axis. The horizontal axis is the level of the practical realization. Vertical axis represents the quantity, complexity. Usual technology, like say Kalman filter, particle filter, some artificial potential method, frequently used in the robotics. It's long time. It's assigned in the bottom, in the baseline. It requires some type of data to regulate or specify best parameter to fit to solve the actual problem, but it's not too much. If it's getting be complex, so many parameters exist inside the system, and so many researchers try to tackle the issue. Then finally they used a kind of statistical analysis to fit the parameter. Then it's a kind of the basement, the machine learning, the deep learning, the Bayesian method, probabilistic machine is used. As you know, Google website, so many data is classified depending on by using this kind of technology. That's why, yes, deep learning is getting be famous according to their this kind of the performances. It proves high reliability if data is massive. Unfortunately, this is depending on the probabilistic learning. That's why if case-by-case data exists, okay, Bayesian scheme doesn't work well. You cannot trust too much the even after the learning if data is not massive. Other side, yes, once you obtain the massive data and then finally tuned parameter because of the learning scheme, but taking time during the learning processes. After that, if it can be generalized, but if data content is frequently updated drastically, data property or tendency are different, yes, such an offline learning method doesn't work well. I originally studied about neurosciences and brain-inspired technology. That's why my dream to rebuild brain-inspired neuromorphic intelligences, as I explained. But it's still far from my position. That's why we need to think about this kind of architecture is possible to reconstruct by using conventional technology, even in the fusion technology. Yes, this is one of the option is a knowledge-based AI. I study about hippocampus episode memory formation in the brain. That's why data-driven AI is very fit to the model learning, unconscious learning. That's why, yes, conscious learning, how you can aware this is true, this is logically impossible. This kind of logical inference or reasoning, it can be solved knowledge-based AI. Green area. Recently, semantic web technology getting me famous and established very concrete technology. That's why we can propose a kind of fusion technology to connect ontology based on the semantic web and deep learning and machine learning probabilistic machine. Here I discuss problem and accountability. Left side, I show a typical clustering view. If you can obtain number of the data, usually we describe it a kind of n vectors, S1, S2, Sn. The data is massive. Then, if you can finally select to load a few number of the dimension to describe the best way to cut off somewhere. Yes, this is a graph parameter 1 and 2. If you can recognize blue data as safe, red data a danger. If you can obtain some hyperplane to discriminate safe and danger zone, this is a successful. This is a typical procedure if you can try to use the clustering method to forward assessment. This scheme can be applied a type of the vehicle assessment. If you assume vehicle speed with respect to the speed limit in road, if you the driving the car in the lane with low speed limit, then your the accelerate speed is very dangerous. That's why vehicle speed high in the range of the low speed limit is danger. That's the red danger zone. If you're riding in the car and under the low, it can be recognized safe. Then yellow area is merging. This is successful cases. It can be generalized anywhere, any cases. This is the issue here. If you can try to treat the clustering method all the way in the road issue, it's dangerous, I have to say. If you can assume, okay, number, okay, this is a sensor value. So many sensor value you can obtain. Oh, people are crowded, that's why very danger. It's not natural. Oh, people only one, that's why safe. Is it true? Yes? It's very doubtful. That's why clustering method doesn't work well all the time in the case of the road assessment. Therefore, we need to think about semantic information, even in the automated driving for accountability. So many car companies achieved automating driving system, sensing the data in front of the vehicle is classified or processed and sent to the control load, then output the control signal depending on the vehicle dynamics. It's finally achieved in so many companies. But I'm proposing now for risk assessment or risk management. It should not be the black box. What kind of the person is in front of you in the car? Oh, this is a pedestrian, bicycle, car, vehicle. I'm running at this lane. Now we are going to right side. This is a symbolization and representation of the elemental data from raw data. It's sent to the upper level of the system to treat accountability, the transparency, the decision making, the automated driving system, artificial intelligences verify this is appropriate according to the traffic law. Then send to the signal as a decomposed semantics at the level of the action plan. Oh, you can go right turn. No, stop the car now. Okay, let's go. It's acceptable according to the situation. Then back to the output. This is a kind of supervision of the artificial intelligence. Let's say red box is the afferent semantics, putting data from the low level and upper level. Then blue box represent efferent semantics, backing the data after the process in the knowledge. This is a truly necessary control of the automatic driving vehicle in a normal road, not highway. How can we treat safety and security as a release? Basically, the concept of safety or safe, it can be treated in the engineering approach. Some international standard evaluation called GIS format, something else. It describes dependability as well considered property, robustness, break-proof and less confusion, and fail-safe as a safe side. It comes. It is broken. It's very important. Based on the human engineering, mechanical engineering, control engineering. It implies we engineers try to embed such kind of countermeasures as maximum as possible. By the way, security, the relief, our mind is not equivalent to safety in the engineering manner. That's why security as a relief should be considered about cognitive aspect of us. Then, cognitive science, neuroscience, information science is highly important to establish this kind of concept and actual implementation method. I propose the concept extension, merging, and option, three axes. It represents time, space, and method. Time means time to judge at the critical moment. Space means space to keep away from risk factors. Similarly, method. How many options you have to avoid risks. It's highly dependent on the property, how humans feel in a possible situation. Therefore, we need to build driver model, behavioral model for pedestrians and bicycles. Here, I try to explain why informatics is very important to combine the engineering method that established long time, such as automated systems. Yes, and surrounding area, white area, I'm explaining some typical or traditional method for the control theory, target tracking, feedback control and feedforward control system, or mode transition. You can change the control scheme depending on the mode. Recently, model-based accurate control is very important, or some multiple strategy done by agent system. However, this is clearly defined by engineer. In the yellow box in the top, it describes the situation encountered in the road. The vehicle may face so many different types of situations, or even your sensor cannot detect a target, but event may occur, some kind of possibility. It may happen, it may happen, it may happen. So many type of the issue you need to think as a prediction or anticipation. Therefore, guaranteed function require a kind of optimization theory to solve the problem. One of the approach is probabilistic model. Other type is a deterministic model. Traditionally, so many implementation methods were proposed to solve this kind of issue. In the basic point, binary scheme, bit or 0 or 1. This is based on the Boolean algebra. If you cannot satisfy there's only 1 or 0, fuzzy control system can help you to represent midpoint, not only the 0 or 1, 0.5, 0.3, something else, a kind of the mediation of the discrete continuous representation. It is based on the set theory. Recently, support vector machine as a self-organized map or advanced way in deep learning and reinforcement learning helps you to classify a data according to the probabilistic tendency. Yes, if you have a multi-dimensional data, if you can easily classify the true or false the teacher data, probabilistic the model can help you. As I discussed, this is not quite enough in the risk assessment. It may happen so many types of issues, not detective things. It's all in the hidden. Our expert knowledge helps the situation If sensor value doesn't appear even with the accurate sensor, yes, we can predict, anticipate what may happen based on the knowledge or some inheritance of the expert people. This is called knowledge-based artificial intelligence, actually implemented in ontology representation. This is a kind of example. The ontology is the hierarchical structure. If you set living things, it can be classified to type, for example, human and animal. Animal decompose the cat and dog and the cow, something else. This is the subset of the set. If such a hierarchical representation is possible, semantic web technology can help you very quick data searching and logical inference reasoning. Finally, I'm simply mentioned about sparse modeling scheme, for example, as try to overcome the difficulty the ill-posed problem. So, I explain modeling. This is a typical modeling and mass point model usually we treat in physics. But it is not satisfactory level because the problem is we need to classify actual cases. Who is wrong in a car accident? Hit the curb. That's all. It's not take responsibility for in the sense of accountability. Therefore, you need to extend a kind of area model to explain the situation more accurately. What is the best model or an appropriate model to explain security as a relief in the sense of the driver model? As I explained, mass point model is not appropriate in these cases. Difficult to classify who is wrong. You need to think about again extension, merging, and option. Then area model is one of the options to think about the three type of the component to organize security in the model. It's apparently hit or non-hit, the binary representation is not acceptable for us in the sense of the accountability in the society. Then we need to think about some complementary design, data-driven AI, and knowledge-based AI. They are called model-free approach and model-based approach sometimes. This is the concept of security as a relief in the driver model. Extension, merging, and option is corresponding to time, space, method. It's clearly described or illustrate is this kind of model. We say this is the area occupational model. We use this kind of picture or mathematics to describe relationship in the sense of the time, space, and method. So I will show you some example from recent automated driving project, focusing on scalability and time and space and issue in information representation. Actually, this is the maps in the same location, but different scale. The left side is described route and midpoint, pathway. The right side shows trajectory. Usually we use the trajectory for x, y, z position in three-dimensional places. It's highly important to control robot, the vehicle, to go from some specific point and destination. The green line that represent different trajectory to go left side. But if you describe different trajectory, putting a different name, it's a bit messy. Therefore, we introduced a set theory. This is kind of representation by using set. We introduce here a set of the representation turn left. Sometimes it avoids the pedestrian, the bicycle, but we call this is a set of the trajectory of turning left. This kind of abstraction is coming from the scaling over time-space issue. And therefore, we need to think about appropriate abstraction level. Then, it goes the question, how do we define temporal granularity? You need to have time and space in the real world, in depending situation and task. We call ba in Japanese to represent the whole sense of the time and space. This is very important, not only in the philosophically, but also engineering and science field. This reflects to the very important issue in the sense of the engineering, but also human intelligence. As an example, the travel, the Mars Pathfinder. This is a famous story in NASA. They had a serious failure and the mission emerged because the trouble in the Mars Pathfinder. Of course, engineers in the NASA finally tuned the program to control the vehicle in the Mars Pathfinder to avoid any of the obstacle. But unfortunately, these cases in the criteria of the program cannot judge this is a rock. That's why Mars Pathfinder cannot recognize this is a rock, then stop the frozen stage. That's the actual situation. Right side, this is a picture in a psychological test to intelligence level for children sometimes. We usually understand, oh, this is a fighting and playing game by adding some additional information called hypothesis. So then we solve a kind of unclear manner. This is the hypothesis-driven knowledge in the intelligence. For us, usually we solve so many complex and conflict issues in the society by using this ability. This is a summary intelligent activity that we have. This is a table with a classification of the intelligent activity summarized by Hubert Dreyfus, published in the book What Computers Still Cannot Do, published 1979. He summarized four types of the intelligent activity we have. First one, associationistic. Second one, simple formal. Third one, complex formal. Fourth one, non-formal. First one, associationistic. It means kind of knowledge or rules independent of the situation and the context. We calculate 1 plus 1 equal 2 all the time, for example. In the second one, simple formal cases, there are some rules. Once we get the rules, we can follow the rule. That's why it can be solved the algorithm. Third cases, even if the algorithm exists behind, but we cannot see easily, so we cannot, if we have to find the rule, we just follow that. In the principle, it's the same as the second. That's why we can apply that kind of the searching algorithm, then realizing algorithm. The recent AI technology can find, because of the data, then tendency or the mechanism behind. It's sometimes called heuristics. But unfortunately, first one is not easy for the robot and the artificial intelligence because there is some serious lack of the information and the vague the rule. This is called ill sometimes. Serious lack is the problem to solve. Therefore, we need to add some additional information by ourselves. This is a situation we have to solve in the non-formal problem. Therefore, first one, conventional robotics I can use. We embedded some rules at the very independent of the situation, the context. Robot can solve maze, for example. Second one, if it's algorithm, we can use the computer program to embed the system to solve problem. Third one, just recent machine learning or the deep learning or some other probabilistic approach can solve to find some background rules, the tendency or the mechanism sometimes. It's very attractive and very advanced. The problem is just how we can share our knowledge in this. There are large extensions of the data-driven AI, the function of the discovery. Sometimes it may reach creativity. But unfortunately, they have no limitation of the life, energy, resources. That's why it's not so easy to share our pain and joy. In the sense, the computer program or the AI, data-driven AI, can difficult to reach our ethical sense, or the how we cooperate, even if the conflict situation, even if there is no clear judgment, or how we can design the law to be forged. This is very social or the non-formal situation. Then we need to think about the knowledge from ancient history, or how we can accumulate it. This kind of things long term. This is kind of expert knowledge and textbook or history and culture. If it's possible to embed this kind of the knowledge in machine-readable way, it may help for supplementary work for the AI technology. This is an interesting example to realize this kind of function in the automating driving curve. TED 2015 and published and TED movie you can find by keyword Chris Armstrong. Then you can see the full movie on this. Google Car finally works as an automated driving vehicle. I noticed one thing. The Google Car stopped in front of the elderly person. The riding on the wheelchair, chasing a duck on the road. Very clear. Unexpected situation happening. Elderly person is chasing a duck on the road. It's very not normal. But Google Car stop finally. That's very outstanding, of course. But if Google Car cannot explain, this is the situation. Elderly person is chasing a duck. That's why I'm stopping. Just a record. I'm stopping. Some risk. It does, but sometimes it doesn't. If it's totally black boxes, we cannot classify the situation truly risky or not. This is the actual problem. This is a scene I discussed. There is some lane with indicator with yellow color. The Google Car is running, then stop in front some against the obstacle. That was a woman in an electric wheelchair chasing a duck. So then Google Car stop. Unknown situation. Google Car finally works as an automated vehicle, that they have that strategy, no human interaction, which means full automation. Even the driver cannot interfere the decision making that the automated driving. This is a kind of the risk for the automobile company, but besides. But the problem is here, I'm focusing on the elderly person in the wheelchair and the chasing duck. It's descriptive or not. If automating driving vehicle cannot stop to recognize the situation, this is the problem actually. Or if it's not risky, yes, Google Car can go the sideway, for example. No one perfect. No robot, no AI perfect. That's why we need to think about risk as a potential accident. That's why if accident happened, we have to take responsibility to explain why it happened. Then we need to improve after such an inspection of the why it happened. This is the actual Japanese project AI focusing on the safe and relief to answer the question how much the system reliable and comfortable in the sense of the accountability. This is a hint. What kind of things robot AI can learn from the human being. This is a YouTube video to record by driving recorder, putting on the front side. Even expert driver, just small mistake or careless attention may lead the crashing or accident seriously. That's why we need to think predictively or extend anticipation. Sometime, okay, we can learn from this video. Oh, this is misunderstanding. It's a bit scary for me if I'm driver of the vehicle. I'm thinking of it this way. Oh, but the sideway, and the bicycle is coming on the road. Even unexpected situation, animals jumping from the other side, or even evil person disturb your direction. This is the actual social situation. This is a hint to make a model of the driver. We know different brain circuits execute different cognitive function at the operation of memory. The horizontal axis in this box represent bottom-up or top-down. Vertical axis controlled or automatic. In other words, conscious function or unconscious function. The white area reflects the habit is acquired, its original brain function or acquired function as a training. It's related to the cerebellum, the basal ganglia, the name of the brain region. This function is not impaired by load of the working memory. It means even if you're thinking some other things, that your performance activity doesn't change. You can drive the car, you can ride on the bicycle, playing piano, there's no problem with that. But below, the gray area, exploration, deliberation are impaired. The level of the capacity or load of the working memory. So this is the kind of the conscious function. You are searching some visual cue, but exploitation, something different, something strange. Deliberation, you're predicting and anticipate it may happen because of the this is a scheme, the logical inference reasoning. Therefore, it may happen. Oh, there's some risk for this. Somebody aware information. The function of deliberation and exploration are highly important in the cognitive control. The sensation is coming from the environment occurred and select basic schema or task-dependent schema. The process the bottom up, but it should be monitored in a secure way by the mechanism and the cognitive control or value system. This is a function, deliberation, and exploration. This is a mapping illustration. The type of the driving task in the middle, and the cognitive ability and situation awareness. And the blue earlier. So, apparently, you know the type of the driving test requires operational task behavior, tactical task behavior, and strategy task, a bit more expert level. It's connecting the cognitive ability, visual perception, visual processing, working memory, of course. It solves the very difficult problem in the society or the situation in the context. Then, of course, perception is very important in the basement, the level 1. Then, comprehension. If information is not enough coming from the external environment, you need to add necessary information to solve the problem, the projection. Then you can generate the schema to solve actual problem. Then it should be organized, fine way, in the consistent manner without any conflict. You can decide one operational behavior. This is highly important, how these 3 boxes connecting the brain do that very easily as you like. Then this is the example of the driver model, focusing on the risk assessment. Blue area represent adaptive behavior. Driver can manage in a comfortable driving in a zone. Yellow zone is a bit risky or near accident. Driver felt at the fear due to the near fatal accident. Then, red area, lost control, impossible to control even by external driver. This can be obtained. The type of access DVE is proposed. Driver vehicle environment. Let's say the factor is not independent of the social context or situation. That's why speed limit and actual speed should be connected. Yes, how much is risky is your speeding up, exceeding speed limit. It's a relational information. For example, other axis, distance with the pedestrian is far. You don't need to think, but it's close. We need to think. But this kind of the axis you can draw. Then we have some mental model of the keeping some adaptive behavior and keeping the blue zone, or sometime you're reaching the yellow zone then coming back again. This is actual mental process you're doing if you're driving. It represents a kind of seriousness for data-driven approaches. Yes, so many frequent events happening in the green zone is a normal driving. So some accident we can obtain as a data, but the serious fatal accident is very rare. That's why number of the data is significantly decreases according to severity. This is a process analysis of what humans do if fatal action happens. See the graph and the left side. Selected schema should be matched the situation. Then if it is, it goes back to normal driving. But if no, sometimes it goes out from the proactive value to may reach critical event. But even though if it's successful bottom-up selection and done, yes, goes back, even if the near crash, but goes back to the normal driving. This is no. it go over reactive barrier, then they reach the crash. Very severe action happen. This is example. Two example I show in crash and near crash. This is the crash cases and represented by the state space. What kind of transition happened from state to space? Then you can analyze the reason why it happened. This is the case, the near crashers. Even if they are very close to the crash, but don't successfully avoid finally in the end state. This is a system we propose according to this technology in the AI project in Kyutech, collaborating with the national project and the Artificial Intelligence Center in the National Institute. We used data-driven AI, of course, for scene analysis, sensor information, GPS map. We need to detect this is a pedestrian, the bicycle, or other vehicle. Then, this is the intersection or not, with a referring actual position. Then, car stops. Besides this, knowledge-based AI is very important to do the reasoning, the logically, and based on the knowledge or traffic law. What kind of scheme other counterparts may do, there's more possibility. That's why database technology, semantic web, can help just finding solution. Then this is a complementary architecture. Sensor fusion also helps. This is the metadata description and matching the actual environment in a real-time way. This is a new advanced AI system we built in this project. So, goes back to the problem of semantics. What kind of representation is necessary or possible? This is an example, ADAS ontology, then specifying the necessary information for vehicle journey. First one, location. Second one, attribute. Third one, control. That's why, yes, some area is prohibited to enter. Okay, we need to assure the places. That's why destination, running lane, traffic status, and so on, according to the locational information, is very important to regulate our behavior to prevent accident. Second one, an attribute specification. The vehicle size, the types. This lane is only available for the bus in specific time zone. Or this is the only lane for the taxi. You cannot enter by the regular vehicle. This is also restriction. Third one, yes, there's so many lanes exist in the road to regulate the car behavior. You cannot turn right, left in this lane, or not turn go back again in the opposite direction. That's prohibition. That's why you need to match the direction selection to go next. This type of information is very necessary to regulate our behavior to avoid risk. This is a map ontology, the blue one, to represent what kind of the segmentation is possible to recognize different types of rules. This is a car ontology, a red bird, to classify type of the vehicle. This is a control ontology, the green one, to specify what kind of motion the vehicle may try the next. And then it's kind of the advanced expert system then to treat if-then rules so many times by hierarchical abstraction of the representation. For example, if a regular vehicle is going forward in regular vehicle, turning right may meet the intersection, blah blah blah. Then you can apply some specific rules. Red part belong to the car ontology. Green part is belong to the control ontology. Blue part belong to the map ontology. We can organize this one simple sentence, but specifying what kind of specification is really necessary for the judgment. Why ontology is effective in this kind of issue? I will show you in the representation called RDF. RDF is composed from by triples, the subject, predicate, object. Then you can see the below. Yes, this bracket includes three combination information. If you want to represent John lives in the Kyushu, then you can describe in the RDF triple John lives in Kyushu, for example. It represents the situation apart in the condition of the road, and you can add some more temporal information. It's called RDF triple. It's used in C Spark or database languages. Originally, RDF triple represents SBO. It can be extended SBOT into temporal triple here. Then, now you can realize the description. If you're monitoring the vehicle situation, my car is running with the speed of 60 km per hour now. Then you can describe RDF triple. Car X running speed 60 km per hour with T. T is minus 500 milliseconds to current time. Now you doubt. This is a database. Okay, it takes time. Even you type in the Google search, it's not accurately comes back 1 millisecond. So, yes, usually semantic web design is not actually guarantee such a real-time feedback, but we are thinking about another things in a more fine way in engineering. RDF implementation method is usually possible in the bottom-up approach. Sensing data, the massive data coming, if streaming process is coming, if you have to treat everything is converted to the RDF data, and inference performance getting worse, because this is the logical reasoning and takes time, even if it's small time. Okay, you need to have supercomputer for that. Therefore, event trigger based processing can be done to guarantee the real-time feedback. The event trigger stream inferences is usually possible, theoretically possible. That's why we implement this kind of scheme in the real vehicle. It's not so surprising things. If you're a game programmer, event trigger is usually embedded in the scene of the gaming, right? That's the conventional technology, but we are very expert to design this hybrid system focusing the targeting problem. This is a concrete example how knowledge-based risk assessment can be done, demonstrated by Dr. Shao. Yes, This is one of the scene in Lane 1, Zone E. Blue curve is existing. It's called car X. Lane segmentation V and car Y. Yellow curve is going to their intersection, termed A. Car X try to go from the section E to D and passing away through the A zone. This is the actual situation. Then we know the traffic road. Okay, car going to straightforward have the priority. Therefore, if there is no signal, you need to think about giveaway. Yes? Semantic web rule language can treat this kind of issue. Collision warning, 이렇게 bottom. car X is collision warning, and the Y is approaching in the intersection, meet together closely. Then F plus F, car Y is going forward. Car X is turning right. It suggested car X should be stopped. Then car X give away for car Y. This is the actual logical reasoning done by semantic web technology called ontology and semantic web language. This is a good example to understand this description. It's called the first order description logic. This is an example. It's a very fine example given by the Professor Taniguchi, Ritsumeikan University, Kyoto. His book, Introduction to the Artificial Intelligence, is a very nice book. So, it represents I have a notebook or book. Then, first order description logic say, I have X, X is book, or I have X, X is not a book. This represents this picture. And if you want to explain the situation, birds except penguins fly. But X is bird, but not penguin. Then fly. It's learn in any of the X. This kind of description logic can be used for the semantic web language. That's why you can describe such collision warning, go forward, turning right, then give away.
こんにちは。今日も安全運転でお願いします。この時間帯はゆっくり通行しましょう。止まってください。歩行者です。制限速度は40キロです。
I will show you the real demonstration. This is a hybrid air system embedded in the real vehicle. This is one real experiment in Hibikino area in campus in Kyutech. So this case is we used not that we didn't use the automatic driving system in the accurate control because of the permission of the pre-section example, but this is the case of the human drivers drive, but AI monitoring then suggests if it's okay or not. So the left side and the real scene, the car is seen in the front. Then right side is a kind of internal processing, what kind of databasing action is happening inside. There is some segmentation to annotate it, different name with a section, then apply different set of the rules. That's why it works well. The car, the vehicle, the pedestrian, the text, the deep learning system. Then this is okay or not in the pathway or stop the car. It can be controlled, suggested in these cases by semantic web languages and working on the real time. Sparkle query is generated, and every moment it depending on the trigger and can verify the actual situation according to such a event triggered streaming scheme. Then this demonstrates how car stops in front of the intersection, then stop again against the pedestrian pathway in front. Finally, I would like to discuss the problem in the sense of the philosophical issue called trolley problem. This is a problem. Actually, it may happen in the real automated driving system in the world. You can see runaway trolley moving toward 5 tire up. People lying in the track. Okay, you're standing next to the lever to control a switch. If you pull the lever, the trolley will be redirected onto the side track, and the 5 people on the main track will be saved. However, there is a single person lying on the side track. You have two options. Do nothing and allow the trolley to kill the 5 people on the main track, or pull the lever, diverting the trolley onto the side track where it will kill 1 person, which is the option for you. A kind of the ethical option. This is an interesting approach. Inspection and all the words, such as ethical judgment, done by MIT Media Lab team. You can also join. It's a moral machine. They launched the website, then provided the question set. They're asking you the 9 types of criterion in this question to judge survivors victims. Then you need to think priority. First one, the number of the survivor victims. Second one, sex, male or female. Third one, age, infant, child, adult, elderly. First one, species, human, dog, and cat. Fifth one, health condition, fit. Athlete, the type of the body or fat body. Sixth, social status, executive, doctor, homeless, criminal, relatives or strangers, the 7. Person in the boat or pedestrian on the road. 8. It's lawful or selfish. 9. In action. You select or not select the active or passive. This inspection done in 233 countries with approximately 40 million people with 10 languages. This is an example of the question. They're asking you what should the self-driving car do. You have to select either one. This is a very critical moment. There are no happy cases, but you need to select one of the options. This is the result. After you answered all the questions, then it appears most saved character, most skilled character as a consequence. And also this shows tendency you take with respect to others. This also a kind of very interesting hint, the risky situation. This is the second page of your result. Then you can verify what kind of tendency you have originally by through the question and answer. Sometimes pet is surviving rather than humans, or how about the elderly person or younger. This is actual tendency including in your answer. These are final pages. There are so many different types of the questionnaire sheet in the website. Then I recommend you to try one of them. This is scientific publication. Just to summarize this result, published in Nature 2018. Self-driving car remember to read that moral choices are not universal. It means it's highly dependent on the culture and the country. This is a summary of the result of the paper published in Nature. They classify 3 categories: West, East, South, as shown in the map. Then, interestingly, the criteria or judgment tendency is quite depending on the country and the culture, which means West, East, South has a different features depending on the individual criteria. This is a summary, and answer is highly depending on the region and the culture. Region and culture were roughly divided into West, East, and South. East as Asia and Middle East, West as Western country and Russia, and South as Central and South American country. But there are exceptions: Brazil in West, France in South. An example of the regional differences: South respondents are slightly more likely to help young people rather than elderly people. This appears especially in the comparison with East. By country, there are many opinions that pedestrians who were ignoring traffic lights had no choice but to die. In a safe and relatively rich country such as Japan and Finland. On the other hand, in Finland, where income inequality is small, the social status as pedestrian and the occupants seems to have little effect in the ethical decision about whether to help. In contrast, homeless people and criminals were often killed in a country such as Colombia, Maybe it's related to the gap between the rich and the poor was large. This is last summary, focusing on the lawful in East and non-utilitarian in Japan. Answers from Eastern countries like Japan, Taiwan, Saudi Arabia, Indonesia were more likely to be in favor of saving the lawful people, those who were working in the green light. Answers in Western countries like US, Canada, Norway, and Germany tended to prefer inaction, letting the curve continue on its course. In addition, Japan does not place importance on the number of lives saved, emphasizing the quality of who is saved rather than number of the people. The tendency can say, Japan is not so much utilitarian. The tendency help pedestrian, the strongest word, is also interesting point. Second place in Norway, and third place in Singapore. On the other hand, France emphasized the number of survivors, while China and Estonia tried to protect the person in the car rather than pedestrian. France has a stronger tendency to help young people than elderly. On the other hand, Taiwan was most often said to help the elderly. Such a similar tendency was seen in the other East Asian countries such as China and South Korea. Maybe as basement culture and the religion are similar. In conclusion, the researcher in MIT organizing this reported this paper said the number of survivors is very low in judging in Japan. In that sense, it is the least utilitarian in the world. Japan is also much more likely than average to avoid intervention. So, I would like to close this lecture. Thank you very much for the kind attention and spending a long time for the hearing this lecture. Thank you very much. See you again.